right, and we will have our last lesson for series, and now we're going to make series for binomial functions, and then we can use products and quotients with known series to combine them to make series for new functions like tangent. So find a Maclaurin series for this function, and we're going to create a formula because k can be any number, and then we'll just create a formula based on what we see here. Maclaurin just means that it's centered at 0. So if we have f of x equals 1 plus x to the k, f prime is k 1 plus x to the k minus 1. And the second derivative is k times k minus 1, 1 plus x to the k minus 2. Third derivative and then we need to evaluate all of these at 0. So when x equals 0, we put a 0 in there and we get 1. We put a 0 here and we get k. Put a 0 here, that's a 1. We get k times k minus 1. Put a 0 there and we get all of that. And this will let us write out the Maclaurin series, which is f of x is going to be f of 0 plus f prime at 0 over 1 factorial x. F double prime of 0 at over 2 factorial x cubed. And we're just going to substitute for those. F of 0 is 1, so we'll start with 1. F prime of 0 is k. So we have k over 1 factorial x. F double prime is k times k minus 1. 2 factorial x squared. Then on the third derivative, k minus 1, k minus 2, 3 factorial x cubed. And so that's the formula we can use when we see something like this. It'll have a number for k, and then we can just start using this progression. Alright, and so we'll just use that same formula. With k being 1/3, the third root. K is 1/3, and now we can just substitute that in here. One-third minus 1. Then we have 1/3, 1/3 minus 1, 1/3 minus 2, this is going to be negative 2/3. So let's just write it as 1/3, negative 2/3, 2 factorial. Here we have 1/3, negative 2/3, negative 5/3, 3 factorial. And if we simplify it, so this will be a negative 2/9 divided by 2, and we get 1/9. And here we'll just have 10/3 cubed, 3 factorial x cubed. And it goes on. And let's try all right, find the Maclaurin series for that one. Pause the video. And we need to think of it as 1 plus u to the k. We can't have numbers there, it should just be a variable. And we'll just say u is 3x, k is 1/2, and then we can substitute it into the formula. And we'll say f of x. So we're just going to use this. We'll go 1 plus kx. But instead of an x, we're going to have u. So we have 1 plus k times u. And here we're going to have 1/2 minus 1, u squared. So we have 1/2 minus 1, u squared. We have 1/2 minus 1, 1/2 minus 2, 3 factorial, u cubed. Then replace the u with 3x, and we can also simplify. So it's 1/2, that'll be a negative 1/2. Negative 1/2 there, and 1/2 minus 2 would be a negative 3/2. Let's replace the u with a 3x, because u equals 3x from the beginning. And here we're going to have minus 2 times 2, so that'll be u squared, that'll be 3x squared, 2 times 2 in the denominator, 2 factorial. Now we have 2 times 2 times 2, so that will have 2 cubed, 3 factorial. U is 3x, so we'll have 3x cubed. And then we have a 3 in the numerator. Okay, so that was the series for binomial functions. Now we're going to use multiplication and division to form series. let's find a series for sine squared, and we can't just use substitution because we would have to multiply sine times sine, not put sine, substitute. So here we have sine x times sine x, and we need to write out the series for sine and then start multiplying. So we have the odd powers. Now we just have to multiply these, which will give us, one way to do it is, let's go ahead and multiply like this. And we'll just find the first few terms, and we'll have to stop there. So x times x, x squared. And then we'll go x times this will be a negative x to the 4th over 3 factorial. X times this will be x to the 6th over 5 factorial. X times this will be negative x to the 8th over 7 factorial. We can multiply this way. And then when we start multiplying to get here, we'll have x cubed times x cubed. So it'll be a positive x to the 6th over 3 factorial times 3 factorial. And we multiply these. We're going to have x to the 5th, x to the 3rd, negative x to the 8th over 3 factorial, 5 factorial. And here we have x to the negative x to the 8th, and now 3 factorial, 5 factorial, x to the 5th, that'll be x to the 10th, 5 factorial, 5 factorial, 12th, 5 factorial, 7 factorial, and we can keep going. But we can just start with this. We have x squared, and these are x to the 4th, and we have all these x to the 6th and x to the 8th. So we write x to the 2nd. And then when we add all of these together, we have 3 factorial as the denominator, and we're going to get negative 1 plus negative 1 is negative 2x to the 4th over 3 factorial. And we have to add all these. We need to get a common denominator. And if we do that work, we'll get 2x to the 6th over 45. And so we'll just say that the function is equal to that series. All right, and here is here we can use division because we know what sine and cosine are. The series for sine and cosine. So if f of x equals tangent, which is sine over cosine, then sine is 1 minus x cubed over 3 factorial, x to the 5th over 5 factorial. Cosine, 1 minus x squared over 2 factorial. Then we have to do long division with this. So we can write this first. And then we'll have all right, we need to multiply by something times 1 to get x. So we'll multiply by x. X times 1 is x. X times x squared is x cubed. X times x to the 4th is x to the 5th over 4 factorial. And then x to the 7th over 6 factorial. We have to subtract. So we work on getting common denominators here, and we will have 2x cubed over 6. This is 120, and that's 24. So we'd have to multiply this by 5. We'll end up with negative 4x to the 5th over 120. And we have to multiply this by 7, so we'll end up with negative 7 multiplied by 7 here, and we'll get negative positive 7 minus 1 positive 6x to the 7th over 7 factorial. Now we need, that's a 1/3, so we'll multiply by 1/3 x. Here we want x cubed, that's a 1, so we have to multiply by x cubed. 1/3 x cubed times 1. 1/3 x cubed times that will give us negative x to the 5th and over 6 and we'll multiply times this, we'll get x to the 7th. 1/3 times that will be 72, because that's 24 times 3, 72. We subtract, that's going to cancel. We get a plus here, and this ends up being 16x to the 5th over 120. And we just go as far as we can. And we know that we have to multiply by something times 1 to get this, and this reduces to 2x to the 5th over 15. All right, so there's a way to use the two known series with division to find a series for tangent. So those are the steps. We'll just have to practice more in class. It's just tedious doing all that work, so we'll practice in class. That's the end of the lesson.